Hi everyone and welcome. We're talking about Oracle Database Programming Section 13. It's going to be discussing tables and creating them, dropping them, doing things like that. And then we'll move into Section 14, which is going to deal with how you protect the data going into them with things like constraints. Before we get into Apex, let's just talk a couple moments about the different objects in a database. So you're used to tables being an object, but there are going to be other things. There's going to be things like indexes. There's going to be things like constraints, which we'll talk about next week. Views, sequences, synonyms. These are going to be some of the things that come up shortly. And basically, tables are one of two things, along with indexes, that are going to take up space. So those are sometimes referred to, you'll see the term segments for those. So something like a constraint is just going to be, here's the rule. So it's just a little tiny bit of text, like, this field can't be greater than 1 million. That's not a very big thing. But a table, on the other hand, there's a lot of stuff that goes into that. There's what we call metadata. There's a system catalog. We'll see some of that today. So, and there are two types of tables. There's the tables that we create, and then the tables that the system maintains. We've seen some of those system tables already, sort of, when we went in and said, let me look at a table, and we say describe. You'll see that gives you information about this table. So if I create a table, it's not just an empty box somewhere. All of this stuff gets written somewhere to an area called the system catalog. So there is a certain amount of overhead that goes into creating tables. If I say select star from user tables, you'll see I have 64 tables here. And this is telling me what tables I have that are associated with me, and that's going to include, first of all the tables that were in that initial script with the schemas that we ran at the beginning of the semester, and then all the stuff I've been using for my videos as well, like the football roster and the instructors and so on. In addition to that, so this is one of these examples of these system tables. We haven't really talked about indexes yet, but there are a few of these that are created. Some of these are created automatically. Some of them were created with the create script. But when we create a table, we, of course, do need permission for that. And we do have that on the Apex system. And what we'd be able to do is we'd be able to create a table. And what you'd be able to start with is create table, and then you would choose to give that a name. And let's say similar to one that I've kind of used as a project, let's say we want to keep track of maybe majors that a college offers. Traditionally, you would write the primary key first, the unique identifier. You do not have to, but generally you would do that. And we can kind of give them names. So for example, we might choose major ID. And here's where we get into a little discussion of data types. If you've taken some programming, and if you're in my class, at least you should have a programming prerequisite, you're used to different data types. So some of the more common data types, you have a character. You also have a VARCHAR, V-A-R-C-H-A-R. And you might say, why are there multiple character? Oh, wait, there's more. There's VARCHAR2 as well. And what you'll find is in Oracle, they'll let you do both VARCHAR and VARCHAR2. You'll see both those are going to be keywords. And this is where we get into stuff that's a little different between Oracle and SQL Server and all these other tools. VARCHAR is standard. VARCHAR2 is going to be Oracle's version that is a little more efficient, but both of them do the exact same thing. And there's also character. So you might say, well, why do we have all three of these? Character is going to be fixed length. So let's say, for example, every major has to be exactly 3 characters. If we know that, that's going to be a good spot for me to choose a character data type and choose it with a size. I know it's always going to be 3 characters, and by having a fixed size for a field, it's going to make the lookup a little bit quicker because it knows everything's going to be 3 characters long. It's going to read that in very quickly. The negative of this is going to be if, let's say, I had a product description that might be up to 10,000 characters. If I do this, and I say character 10,000, it's going to reserve a block of 10,000 characters for every record. So what that means is if I have 2 characters there, I am wasting 9,998 characters worth of storage on nothing. And that's where this variable length character, or VARCHAR, comes in. Now you could still set a maximum, but if I were to say VARCHAR 3, that would mean up to 3 characters. And if I were to say VARCHAR 2, 3, it's the exact same thing. It's just this is the Oracle version of it. Let's say I had a major that was 1 character long. This would save you 2 characters worth of storage because the VARCHAR only allocates as much room as it needs to store that, versus a character is going to say thou shalt be 3 characters no matter what. We're blocking off 3 characters for it. So if it's something much larger, you would use a VARCHAR or VARCHAR 2, depending on if you want to use the Oracle stuff. So if we were talking about something like a description, that might be something where we might use a VARCHAR with a larger number. Let's say we have a major, like for example, at Bergen, we have CIS and we have INF. So we would go through and we would define the different fields that would be associated with that. So we have a major ID, and something like major name, I would probably choose VARCHAR 2 for, and maybe pick, I'd look at the data and do this a little better if I were really doing this, but let's say the major name could be something as short as biology or something as long as information technology. You can see there's a big difference in the number of characters there. That would be a spot where I would use this variable length character. You'll see that these are separated by commas, by the way, so commas here. Something like description, where it says this degree will blah, 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 blah. That might be also another spot where we might use a variable length character. And this right here would be just a basic table description. Now, the one thing we didn't do here that we probably should do is to define a primary key. And the way that you can define a unique identifier and do a number of other things is following the field name, following the data type, but before the comma, you could put in some modifiers. So for example, primary key. And just so we see a little more variety here, I'll show you one other thing. We'll talk about it. But you can also throw in commands like not null, and that would indicate that the major name is not allowed to be left null. And when we run this, similar to last week, we don't get any sort of data on the screen. We just get that a table has been created. Now let's describe this and see what it looks like. And we'll see very much like I just set it up. We have the table name is college majors. It has 3 columns, the major ID, the major name, and description. The major ID is a character of length 3. You'll see the primary key here is set to 1, which is going to indicate that this is the primary key, unique identifier. Because it is a unique identifier, it cannot be left null, and that's why you see there's no checkbox for nullable. Major name, we said, is a VARCHAR 2, size 25, and not null. And what that did was that set it to be not nullable. And major description, since we didn't tell it otherwise, it's going to assume that that can be null. So these are some of the more common text formats that we would find. Let's take a look at some of the other data types that show up sometimes. So let's say we're keeping track of student information. One of the big questions becomes, well, primary key, even if it's going to be a number, should we make that numeric or not? So there's a couple of fields that may seem like they should be numeric that actually are often string. And the reason, there's 2 reasons for it really. First of all, if we know the length is a certain size, like 7 or 8, we can do that. And it's also more easy if we need to put some sort of validation rule in there, like the second number can't be 2 or something like that, or can't end with a 9. Like there's different rules you could put in place if you needed to. And the other reason is leading zeros. This also applies, of course, to zip code because, especially in New Jersey, we have zip codes that start with 0. Up in the Northeast, Bergen, for example, is 07652 is Bergen Community College's zip code. So if you store that as a number, it's going to remove that leading 0. So anything text-based should be a character, of course, but If it's a number and you're not performing math on it, you would often store that as character as well. So student ID number, social security number, zip code, PIN number, anything like that might be something that you would store as character. So the nice thing about VARCHAR and VARCHAR 2 is you don't have to be quite as precise when you're putting things together. So if you knew characters, you'd have to kind of think about this a little harder. In this case, you kind of look, what is the largest value you would expect? And 40 sounds like a lot, but keep in mind people do hyphenate last names. So, that sort of does show up. The state of New Jersey, actually, for a long time, I'm old enough to remember this, the driver's licenses stopped the first name at 10 characters. And the first student I encountered who had that problem was a student named, his first name was Abdel Fattah. And that's 11 characters with an H at the end. And you say to yourself, well, there's not that many Abdel Fattahs. Second name I encountered from one of my students, because we talk about this in database classes, Christopher also has 11 characters. So for many years, people whose names were Christopher, their licenses in New Jersey would get cut off as Christophe because this was their database design. Now let's take a look at a couple of other fields that might show up here. First of all, I might think of something like date of application. And there are fields for date, for time, and timestamp. Dates are really a pain because you have to worry about time zones and such. We'll get into that a little bit. For the moment, I'm just going to say that this is going to be a date, and that's going to store that date in the default Oracle format that we've seen. Let's say they were storing your picture. That would typically be stored as a blob. Blob stands for binary large object, and that would be our way to store like a large picture. There's a smaller one called raw, but if you're using files, you're probably using blobs. There's one called clob, which is a character large object. That would be something, and the character large object would be used for something such as JSON. JSON is going to be a common file format for web applications. XML is another format as well. Blobs are going to be used for things that would be, binary images. That's video, picture, could even be like a spreadsheet or, any sort of PDF, things of that nature as well. There's another data type called Boolean, which is a true or false, or typically null, although it's not always used by all of the tools of all the DBMSs, but we could go in there and say something is Boolean, which is going to indicate either true or false or null for that. And let's say we wanted to store something like grade point average. Now, typically, you don't store this as a number. You would calculate it, but just bear with me here. We could even say high school GPA or something if you want to be a little more specific about it. Now, with the number data type, you would go in and you would say how many total numbers are going to appear there, followed by a comma if you want, and then the number of decimal places. So this would be 3 total numbers to appear after decimal place. So this will go from negative 9.99 to positive 9.99. And at this point, aside from maybe deciding that the student ID number should be a primary key, this would be a pretty complete table showing some of these other data types. And actually, it looks like the version of Oracle on their server doesn't support the Boolean data type. You can see we are getting an error here. But what people would typically do is you could either set this as a number, a 0 or 1, or a character of length 1 and say it has to be, Y or N. But for the moment, we'll remove that. And since I'm trying to run this more than once, you'll notice that I do get an error that name is already in use. So you can absolutely, if you need to, drop a table. And what you'll find with a lot of creation scripts is they typically start with this. just to make sure that you don't run into this exact problem. Like if you run the same script twice, you might run into problems. And what this will do is it will drop that first table and then recreate it. So you can see that would drop the table, and this would then create the table. And now you can see this is going to be the layout of our table. You can see we've got all the fields that we've created with the various lengths. You can see the number. It tells you the precision is 3 numbers with the scale of 2. So that means exactly what we were seeing before, 9.99 to negative 9.99. Now there are some other data types. I don't want to demonstrate it because I don't have another system I can really hook it up to. But Oracle also does support having outside tables from another system that you are able to access. So if you ever see something like this, you would have a list of fields after this that would map it and it would give you a path to that. But the table would be followed by an organization external, which is going to tell you it's outside the Oracle database, and it would probably use a tool like the Oracle Loader at that point. Now, the other thing I'll mention, and again, some of this stuff is not supported by this version of Apex, but there is also a data type called vector. And I'm going to mention this because it's very big with AI at the moment. And basically, when you are doing any sort of AI work, the way it knows, like, Pepsi is similar to Coke because of, X, Y, and Z. And then Pepsi is also similar to water, but in kind of different ways. Like, obviously, they're both colas on one way. They're both beverages on another way. The way it figures that out is using a thing called vectors. And vectors are, if you've taken any physics, it's a directed line. The vector is going to be a way to map what a word, a phrase, whatever means. So there is a data type for this in Oracle. It's just not in our version of Apex, but it is absolutely there. And just to put this out there, if you are interested in pursuing these, you'll see that they do have, Oracle has a number of AI certifications. And just like this class is kind of geared towards the Oracle ecosystem, same with this AI stuff. They have the Oracle AI Foundations, Oracle Generative AI Professional, and Oracle AI Vector Search certifications. I actually have all 3 of these. I just got this one a couple months ago, 3 weeks ago or so. I finished the AI Vector Search Professional. I'm not saying this because I'm a big, Oracle person. They had a program this year where they gave out free certification exam attempts, and I like free stuff, so I took that as an opportunity to get the 3 AI certifications. So this would be a spot if you, connect with me on LinkedIn. If I see stuff like this, I mention it because I know spending $200 on a certification exam is a lot, especially if it's not something you're comfortable with. I know Microsoft has done this in the past. I have a number of students who got their Azure fundamentals for free. So there are a number of different certification exams that there are offers every once in a while that pop up that you can get free attempts on these. So, and just as an aside, if you've made it this far in the curriculum, if you've gotten this far, you're very close to this Oracle certification. This is the SQL Certified Associate, and the course that you're taking is actually geared towards this certification. So if you have completed the course and you've done well with this and you feel comfortable with it, it never hurts to lock in that knowledge. Again, whether you're my student or elsewhere, people might not know, oh, well, I don't know what you learned at this school, but if you have a professional certification, it adds a little more cachet to your resume. It gives you a little more, makes your resume look a little more valuable. So let's take a look very quickly at the date and time functions as well. If you recall, this is the sysdate, and there's another one called systimestamp that exists. And these will let you see what format the system is storing their dates in. And you can see down bottom, this is going to be, I promise it's not 4:35 in the morning where I am. You can see it's about 11:35 at night here. So because I'm 5 hours off of the the main time zone, the Greenwich Mean Time, which I'll show you in a second here. And remember, from dual is just their way of letting you select from nothing. So if you want to store time and date stamps, you can either store the date this way, or you can store a timestamp, and that's going to have the date along with this time here. So the +00 is going to be the way it represents time zone. So you can see right now it says it's November 17th at 4:35 in the morning. I'm on the US East Coast, which means we're 5 hours off of Greenwich Mean Time, or what we call UCT, Universal Coordinated Time at this point. But there's so many time zones. Like, there's weird stuff, like, I guess it's weird if you, not weird if you live there, but there's parts of the world where they shift by a half hour. But if you take a look, Australia, it's off by a half hour in certain points. Indiana has a fun one where they've split it up by county. So certain counties are in central and certain are in eastern. So theoretically, if you're in this county here, and I don't know my Indiana counties, but this county right here would be in central time, while this further to the west is in eastern time zones. So this idea of time is kind of weird when it comes down to it. So I've had a couple jobs where I had to swipe in, swipe out when I show up. Now the other thing that's, just to add this in there, you also have the problem of time zones twice a year. The hours change as well, so you end up switching your clocks ahead and skipping an hour or jumping back an hour. So that's why typically having some sort of time zone and using that, Universal Coordinated Time, or UCT, as your base, and then incorporating the time zone either where you store it or when you display it is more common. That's why a lot of websites, they'll have you set the time zone. And if you've ever been on a team with people in different time zones, you know how much of a pain it is to keep track of that. So what I'm going to do, just to show them both, you wouldn't do it this way, but one swipe in, one swipe out. They're both going to be timestamps. The swipe in is going to be timestamp. The swipe out is going to be with the time zone. We'll create this table, and I'm going to use our insert command, as we talked about in the previous section, to insert the exact same number, the exact same value really, into both of those. And this should show us really the difference between the two. So we can see the swipe in shows up like this, swipe out shows up like this with the time zone appended to it. Now you might ask yourself, well, why is this not showing up in my local time? And the reason is it typically is dependent upon the server configuration, not my local computer. And I did poke around, and I don't seem to have permissions because I'm not an administrator on their server to change my time zone. Finally, let's talk about changing a table. Table designs may seem pretty final, but they definitely do change over time. I'm old enough to remember when we had a pager number in our college's database, where your professor might look you up and send you a page, and then you'd call them back. I never used it, but it was still in the database when I started teaching back in the Stone Ages. Something like a pager number might be removed. Something like an email address might be added. I'm pretty sure everybody's got an email address in the school system, a home one, as well as a login ID. And those are new fields, that's definitely in my even professional lifetime that have been added. So we might have stuff that does need to be changed here. So if we're ready to add a new field, we go alter table, and we give it the name of the table. Notice no extra parentheses because you're adding columns typically one at a time. We would say add, give it the field name, data type. Notice we're choosing VARCHAR 2, and table is now altered. Let's see what happened. By the way, the fields will go at the end, so it's not like you're in Excel and you insert a column and shift stuff around. New columns will go at the end here. And we can see we've got ourselves a brand new column. Now, what happens if we have 20,000 students already in our database? What happens to them? Well, those values are going to be null for the folks who were already there before that field existed. Now, we want to get rid of a column. it's very similar. We alter the table, that stays exactly the same. And then we would say drop. We have to give it the column keyword, and then we give it the name of the column that we wish to get on out of there. And let's see what that looks like. And success, our picture field is gone. Now notice, by the way, there is something called a recycle bin. And we could see earlier, because as I've created this, I go through it once, I have to delete it so I can then demonstrate it. Notice that my earlier student info table was dropped. That goes into a recycle bin. So let's take a look at removing tables and let's see what happens. So notice I do have a roster copy from a previous video. And if I give that a run, you'll see that it now shows us that the roster copy table was dropped. There are going to be ways to restore that if I need to. We can use something called a flashback. And we can use this command to try to restore that. Now, I would never want to rely on the recycle bin here, which is why backups are going to be very critical, but we can see that brings back the roster copy. So that flashback is there because stuff does go into this recycle bin. This is not standard across all DBMSs, by the way. Now, if this contains sensitive information and we really want it gone, we can bypass that. And that's like in Windows, you can delete a file or you can just have it bypass the recycle bin. So we have the ability to purge that. And now if we query our recycle bin, we'll see that that is not in the recycle bin. So purging bypasses that bin. So I've created a copy of an albums table just to have one other thing to demonstrate here. Now you do have the ability to just delete everything from a table if you need to. And what the difference is if you delete it, it keeps the structure. So your constraints, your primary keys, your fields, your field names, all that stuff is still going to be there. But if you just want to get rid of all the values in a table, let's take a look here. We see albums copy has 66 rows in it. So we could certainly go in and delete from there. But the problem is delete operations take a while. And what we can do is we can now truncate the table. And you'll see that happens very quickly. You'll see it says no data found if we do try to do a select star. But if we describe it, you can see it does still exist. So the table's here. It just has lost all of the data in it. Versus a drop, we'll get rid of the entire table. And if you try to describe that, you'll see it cannot be found. So let's say we need to change a table's name. So we already have a table called students that I don't want to mess with. I'm going to use student example here. And we'll see that we can rename a table. And of course, at that point, we see the table has been renamed. Now, the last thing I want to show here is notice we have this comment field. Let's say somebody is a database administrator and they bring on a new employee. In order to help them, in addition to some of the documentation we talked about earlier in the semester, you can also add comments. So you can add a comment to a specific column. For example, in this case, comment on column. And you'll see that we have to give it the table dot column name. And now if we look at the description for the table, we can see that we now have this comment that appears there. Now we can also add a comment on a table, which we could see here, comment on table, and then we give it the student example table is, and we give it an appropriate comment. Now that's not going to show up in the describe for the table because it's really more about the columns, but instead there's an entirely separate schema, user tab comments. And this is why we said that tables are considered segments, that they're taking up more information than you realize because there's all this stuff, populated around the database all about this. This is what we might also call the metadata. The key takeaways, create table command, why you need to use character versus VARCHAR 2, why timestamp uses the time zone, how number types work, and what is a blob. Those are the main things you need to worry about when you're creating the table. In the next section, section 14, we'll get into adding constraints, adding a primary key, making sure a field value meets a certain range. For example, your salary can't go negative, things like that. So we'll take a look at that next time. Until then, take care.